Hey, welcome back to Fat Mom Physics. This video is actually going to be very short. We're going to be finishing up 3.3 Subtracting Polynomials, in which we just have two examples left. Example 4 and example 5. So, let's get started. Example 4, which polynomial must be subtracted from 5w squared, essentially this guy over here, to get this? So if you're just staring at the question, it's not going to make sense. Try to write things down whenever you're stuck. So essentially what this means is if the polynomial must be subtracted from this guy over here, then that subtraction statement means this thing minus some polynomial that you don't know. So this becomes 5w squared plus 3w minus 2, all of that, minus some unknown polynomial, which is going to give you minus 7w squared plus 5w plus 1. Oopsies. So that is what you're trying to do. You could try to brute force it. What that means is you could say, well, I'm minus 2. If I have to subtract something to give me plus 1. So working backwards, you think about it. If I subtract a negative number, I'm going to get a positive number. And I have to subtract negative 3 to do that. Because negative 2 minus negative 3 is going to give me plus 1, because that's minus 2 plus 3, essentially. Okay? So you could brute force it that way. And to finish it off, it will look like this. So 3w minus something gives me plus 5w. And of course, that's going to be minus 2w, because 3w minus negative 2w will give me 5w. And then 5w minus, I need to subtract something to give me minus 7w. So this one, I'm going to need a bigger one. So I have to subtract about 12w squared. So that 5 minus 12 gives me negative 7w squared. Now, doing that all in your head is a little bit challenging. So I actually recommend another strategy for this. Remember what I said before? Another way to give you a clue on how to solve something is to think of a simpler example. So imagine I knew the number 10. I need to subtract a number to give me 3. This is exactly like the scenario that we have. We know the first number, we don't know the second number, and we know that it equals some other number. So 10 minus something we don't know gives us 3. Well, you're thinking about 7 right away, but think carefully how you got the 7. And you probably did 10 minus 3 to give you that the box that you don't know, which is 7. So why won't we do something very similar? Why won't we take this guy and we subtract this guy to give us the middle answer? Okay, so let's do that. And if we write it all out, it's going to look like this. I have 5w squared plus 3w minus 2. This is one polynomial. I'm going to subtract negative 7w squared plus 5w plus 1. And we know when we subtract polynomials, we just have to flip the sign of everything inside the second polynomial, then it becomes an addition statement. So this looks like 5w squared plus 3w minus 2. Flip the first one, which becomes positive. Flip the second one, becomes negative. Flip the third one, becomes negative. So now let's go ahead and add them together. So I have 5w squared and 7w squared. That's going to be 12w squared in total. Next up, I have 3w minus 5w. That's going to give us minus 2w. Last but not least, I have minus 2 and minus 1. So that is minus 3. Hey, and voila. This is exactly the same of what I had above. Okay, so that's a strategy you can use when you are stuck, is to try to think of different ways to approach, to simplify things, to help you kind of model something in a simpler way. Then you go back to treat the original situation based off what you learned in your little model that you've made. Okay, so that is example 4. Let's look at example 5 now. Example 5 is the perimeter of the rectangle is the following. Determine each unknown length. Well, based off of this diagram, we know that the bottom here must also be 4t plus 6 since these two lengths are the same. We don't know what's remaining on this side, but we do know that they share the same length since of these two, the dashes tell us they're the same length. We also know that the perimeter is this one, 12t plus 28. So what we can do is, well, we've determined this length here, so that's done. So we can write a sentence to describe this. We know the perimeter is 12t plus 28. And for a rectangle, we know that for a rectangle, our perimeter is our two L's added together plus two W's. Okay, so let's write this out. We know this is equal to 4t plus 6, since that's one of the lengths. And then we have to add the other one, since that is also a side length. But we don't know the width. We do not know the width. So what we can do is, well, we know that there's two of them. So why can't I just say this is 2w? Okay? 2w, and you might be thinking, ew, there's a t and there's a w. What do I do? Okay, just leave the t alone. Okay, we don't know anything about the t. Just forget about it. What we are trying to figure out is what w represents. So let me actually, to make this a little bit more clear, let's make that blue so that we know that w is we want to figure out. That's more important. So let's simplify this a little bit more, in which we're going to get 12t plus 28, and then this is going to be equal to 4 and 4t is going to make us 8t, 6 and 6 is going to make us 12. Okay, and of course that's equal to 2w. Now what we want to do is essentially we want to make 2w, we want to know what 2w is, even if it's a combination of things. So if we go back to our original sentence, in which our perimeter is the lengths plus the widths, if I want the width, or even if I want two widths, this is my perimeter, my total perimeter, minus the two lengths, like that. Okay, and what that means is I need to take this whole thing and I subtract this is going to give me my two widths. So if I wrote that out, it's going to look like this. My two widths is going to equal, okay, so that's this guy over here, my entire perimeter, maybe I'll put that as green, okay, which is 12t plus 28, and let's treat that as a polynomial, and let's subtract the two lengths. And I've already done that here, which is just subtracting each of the lengths, and the sum of them is just 8t plus 12. So I just subtract this like that. After I subtract that, I'm going to get 12t minus 8t, that's going to be 4t. I know I'm skipping a few steps. 28 minus 12 is going to be 16. Okay, so I get 4t plus 16 is equal to 2w. Okay, so this here is 2w. So to figure out the w here, what we know is 2w is equal to 4t plus 16. Or we know that w plus w is equal to 4t plus 16. I'm not going to use the division yet because we haven't quite learned about distributive property. Maybe you have, but I'll do that as a second scenario. So I have two things that add together is going to give me 4t plus 16. And these two things have to be exactly the same. So what that means is if I split up 4t plus 16 exactly in half, I need two things added together is going to give me 4t, and that's going to be 2t. So 2t plus 2t is going to give me 4t. But then I also have to think about the 16. I also have to think about how to split the 16 in half so that whatever adds itself is going to give me 16, and that has to be 8. And if I check that, 2t plus 2t is going to give me 4t, 8 plus 8 is going to give me 16. And that's just equal to 1w. If you did it the distributive property method, then you know that you have to divide both sides of the equation by 2, meaning you have to divide both the 4t and the 16, in which 4t divided by 2 is going to be 2t, and 16 divided by 2 is going to be 8. Okay? And of course, you can check 2t plus 8 plus 2t plus 8 is going to give me 4t plus 16. Okay, so the width is 2t plus 8. There you go. Okay, so hopefully that made a little bit of sense. Okay, I know we won't do distributive property until maybe a little bit later in this unit. In fact, maybe coming up next. So I thank you for watching. I wish you the good luck with your practices, and Fam of Physics, signing out.